So good afternoon, dear participant, and this is our last session of this course. The topic of this session is on societal applications of GNSS for location-based services, especially for the civilian and governance sectors. So today I'll be basically giving you the idea. So how this particular technology or GNSS technology is being used for different activities in the society. During this course, you must have gone through all the technical or technological aspect of GNSS, and we discussed mainly basically about the navigation services and its possible application. But this particular topic is not new for you. You all are using this location-based services these days through your mobile. And let us start the topic and discuss the major application of GNSS as a location-based services in the society. So first we have to understand what exactly it is that is called as a LBS, it's a location-based services. It is basically, it provides personalized services to mobile users based on their current location. You know that when you are having a mobile device in your pocket and you are roaming around your locality, you can get variety of services through various service provider, and basically it is based on your location, and you can ask the question, where am I? Suppose you are standing in a particular location in the city, so you can simply ask your questions, what is my location, where I am exactly standing right now. So you can use the GPS receiver of your mobile to get your location, and basically this GPS receivers generally will interact with the satellites available as the GNSS satellites, and then it can give you the location. If you have the internet connectivity available with you, the similar location you can also get through the location of your the ISP towers from where you are getting your signals. That is also possible. But in general, the GNSS based locations are considered as a more precise location, because when you are using the location services through your GPRS or through your mobile operators, this location is having some inbuilt error that is basically around 500 to 800 meters. So in general, when you are using the GPS kind of services, then this error will be reduced or minimized, and your accuracy will reach up to the 15 to 20 meter accuracy. But if you have the better receiver, like you have DGPS kind of receivers, then you can get your accuracy up to few meters, like 1 or 2 meters. So once you have this location, so then you can ask the question that, like, what is the nearest restaurant or bus stand, shopping centers, hospitals? These all things you are doing actually with Google Maps or similar kind of mapping applications. But actually, exactly how they are able to serve you such kind of services. Basically here, what is happening, the operator services are available basically through some ISPs or service provider, and here I can say your GPS providers, which is United States of America, their space agency NASA is providing this GPS service free of cost to all over the world. So they can also be one of the operators of services you can use for the tracking purpose. You can also use this service for assistance, that you can look for your requirement. For example, suppose you are having your GPS location with you and you are in some very uncomfortable or situations where you need the help from somebody, then you can simply send this location information to your friends or family, or sometime to the police control room, so that they can send the required assistance to you immediately, so because your location is known. So then in later stage, if you try to understand slightly in technical details what exactly it is, this location-based service is very popular these days. And if you see the definition, there are many definitions. If you search on internet, you'll be getting hundreds of definitions. But typically, it is an information service accessible with mobile device through the mobile network and utilize the ability to make use of the location of the mobile device. So basically, it is tracking the location of device what you are carrying with you, and this is the definition. It was given by researchers, Varentas et al. In 2001. But you may be knowing that there is a international organization or non-profit organization called OGC, that is the Open Geospatial Consortium. This organization is a very popular or important organization in geospatial domain or geospatial community. They basically design the data and information standard or service standard for different type of geospatial data. And the definition given by the OGC in 2005 is like this: a quote, a wireless IP service that use geographic information to serve a mobile users, any application service that exploit the position of a mobile terminal, that is called the location-based services. This basically, so if any application, any software application is using your location to provide a service to you, then it is known as a location-based services. Now, what and how it works basically, it is working by integration of various technologies together. So here, GIS data, basically the maps are playing a very important role, because when you are tracking or identifying your location, and based on this location, if you are looking for some services, so of course you require the map in the background. So only getting the location in the form of the latitude or longitude or altitude may not be sufficient, because ultimately you have to look into the possible services or available services nearby locality. So in that case, the role of GIS data is very important. Then we have a very important thing is your internet, because ultimately these maps or data or GIS data are served through the internet. These things are not stored into mobile devices, because you are consuming or accessing this data from the servers, and here the connectivity is playing a very important role. The another important thing is the mobile device. The mobile device or your the instrument or electronic gadget what you are carrying with you is a very important tool here. Without this, you cannot get this location-based service at all. But it is not necessary that every time when I say the mobile device, it doesn't mean it is a mobile phones. It could be any kind of PDA. You can also use your laptop. You can also use your tablet. Any kind of mobile devices what you can mobilize along with you can be used for this location survey services. So basically, the LBS is considered as a very intersected areas of these three domains of like GIS data, internet, and mobile devices. So this area is known as the location-based services. And here you have to understand very important thing is, if you are not having the internet connectivity, then you can ask the question, then can I not get the location-based services? But yes, it is possible. If connectivity is not there, still you can use this technology. But in that case, you have to transfer a lot of GIS data into your device, so that your device should have the sufficient computation capability in terms of storage, display, memory or RAM. Then definitely you can use location-based services. In that case, generally, we may not use your mobile phone as such, but it may be some PDA, or it may be your tablet, or maybe laptop. In that case, definitely you can use your location-based services, because as I told you, the coordinate what you are getting, if you are getting through the satellite phones or through the satellite, not through satellite phone, through the satellites, then internet connectivity is not required. Please remember here, sometimes we are confused that if internet is not there, then my location will not be available. It is not the case. If internet is not available, you have to switch on your GPS into your mobile, then definitely you can get the location without internet also. So in that case, location-based services can be made available to you. So here, how it works basically, here you know that we have satellites in the orbit, and these satellites are basically called the global navigation satellite system. Here typically example is GPS, Navi, GLONASS, Beidou from China. There are so many examples are there for this kind of services. So basically, these satellites are giving you a personalized positioning system, and then you can receive these signals into your device, and then basically you can transfer your location through a internet medium or communication to a location-based service servers or LBS servers, and these servers are basically responsible to get your location, and based on this location, they will basically serve the required data to you through again the internet mode. So here the communication is very much required because ultimately the services has to transfer from the server to the client. So if you see the client, the component of the LBS, they include the most important is users. Then we have the mobile devices, data and content providers, services and application provider, communication network, positioning technology. These all are the component of location-based services. Already I discussed in the last slide that which are important component, and here these things are summarized in this slide. Now, if you see the application of these location-based services, we can use these services for mapping purpose, for geo notifications. You know that mapping is very simple things. By using the GPS coordinate, you can simply map your point locations. If you are moving around the areas, you can also create the lines and polygons. So all three geometry can be easily created by using the location. The another important aspect is geo notification, which is getting very popular these days. You know that based on your location, you are getting the notification from the different service providers. For example, if you subscribe these geo notifications, suppose you are near to a shopping mall, then automatically the different offers from this shopping area may directly come to your mobile phones, so that because they knows that you are nearby their location. So this kind of services are enabled today. So geo notifications are very popular because these notifications are coming to you based on your location. And these days, many service providers like online shopping sites or maybe some other service providers are using very frequently for their customer services. Another important terminology which is very popular these days called geofencing. Yesterday, Mr. Kamal was discussing about the geofencing. This is another very interesting domain. In coming slide, I'll be discussing more about it. It is basically a virtual boundaries or a virtual fence what you can create based on your location, and then you can get a very innovative kind of services on hand, and then you can utilize these services. Another thing is geotagging. This is geotagging of different activities. You know that this concept is getting very popular these days. You must be hearing in the news, media and other places, especially for the government sector. Government is very much engaged in geotagging activities for their different infrastructure development programs. For example, suppose government is building any watershed development program, so then they basically geotag each and every activity to build a complete inventory of this system, so that the location-based queries can be performed on this data set. Similarly, you are also using geotagging for different activities in your social media. Like suppose you are uploading any photo in Instagram, so that time your location is tagged there, so that the Instagram can use basically this location information to popularize your post or to basically market this to your possible sometime users. So that geotagging is very important. In fact, if you are posting some content in the Twitter today, these are all geotagged. Your location also is attached with this posting, so that they can understand the sentiment of the public or the crowd, and accordingly they can show you different type of ads in your basically platforms of the social media. So asset tracking is another examples where this location-based services are very frequently is being used. I discuss about it. These asset could be any kind of things, like suppose example, you are basically creating a assets for you are building a house for some government schemes. So all the houses are geotagged so that you can see the distribution of these houses and also the people living in this house. And another important areas where these location-based services are very frequently used is a transport tracking and monitoring. You know that it is very much required by the citizens, especially if you are using Google Map these days. If you see there the traffic map of Google, you can see the complete condition of the traffic in your area locality, and you can see the what is the condition of jam, either the traffic is slow or moving smooth and all. for this purpose you are using in the Google Map. But generally, the transport tracking and monitoring is very nicely used by some service providers like your emergency services. For example, suppose you are calling a ambulance, so very easily they can track the availability of ambulance in nearby your locality, so that they can choose the correct ambulance and they can mobilize to your local location in the time of emergency. There could be many such applications, but you have to remember that transport and tracking is one of the very important applications where location-based services are very frequently used. In the defense sector or strategic applications for the security and surveillances, this particular technology is very significant, and in fact they use for different type of military operations. They use for this particular location-based services for the target detection in the military. So there are a number of things where they can use this location for their strategic applications. And business analytics is one of the very, very interesting and emerging area where this the companies like insurance companies, or maybe some the shopping site, or maybe some other business, they can basically use this location-based services for tracking their customers, to understand their behaviors, and to understand their likings. Based on this, they can basically serve the better services to them. It is another very important things. And here, in overall, what you have to understand, the right information in right time and right place. This is a objective of the location-based services. Please remember, right information in right time and right place. So if you remember this quote here, then you can think how many kind of, or how many such services will be existing today in our daily life. I was talking about the geofencing, and I thought that this topic would be a very interesting topic for you. It is basically a location-based service in which an application or software uses your GPS or GNSS signal, or sometimes the RFID, or sometimes the Wi-Fi or cellular data, to trigger a pre-programmed actions when a mobile device or RFID tags enter or exit in a virtual boundary set up around a geographical location known as geofence. You know that this is a boundary. Suppose I want to restrict my team or my somebody basically to limit within this area. So I can create this virtual geofence in my software, and then I can install one software into the mobile device of my the person who is going to in this field. Then if any time the person is crossing this geofence or this boundary, then automatically beep will come or alert will come, so that they can restrict their area. And this kind of technology is used for mapping purpose. Suppose you are mobilizing hundred of thousands of your team in the field for some activities, and then you can assign a geofence to each team that you have to complete the task within this range, another geofence for next team, another geofence for next team, so that the duplication in the survey or data collection can be avoided. Similarly, geofence can be used in the, suppose in sea surface, suppose in the ocean region, fishermen, they are moving for fisheries activities. If you have a geofence and some device is given to them, so they cannot cross their country boundaries, because you know that these are the very normal problems that what we are seeing, that the fishermen from India are crossing our boundaries, and then they are basically trapped in some other problems. So this kind of problems can be avoided here. Similarly, for in the border areas, for the strategic applications, we can create a geofence of our boundaries, and then the patrolling units or the defense staff can move as per the requirements, so that they should not cross their borders. So these are some examples, but very interesting area which is very popular these days. And if you have interest, you can further explore it. And we are very frequently using this kind of applications in our day-to-day project activities. And I thought that it will be interesting for all the students, especially those are interested in the location-based services. Another interesting thing what we could not cover in this course was indoor positioning. You know that the location what we are getting today is through the GPS or GNSS satellites. This you can get in a open areas. If you are sitting inside a room or inside a cemented roof, then you may not get the GPS signals. In that case, the locations cannot be tracked. So, but here in some cases, especially when we have a very big infrastructure or buildings like a museum kind of things, or maybe we have a big building for where we are running a lot of activities. So that time, sometime we require the location inside the cemented roof or in the closed area as well. So for this purpose, your GPS system will not work, your GNSS will not work because these signals will not be available there. For this purpose, we use another important technology called a Bluetooth-based beacons, which are very small radio transmitters and wireless devices which work on the Bluetooth low energy technology. And here these beacons you can install in a different part of your buildings or your areas where you require the location-based services. In this case, the same concept of triangulations what GPS or GNSS are using, we can use this concept to get the position of an object. And here in this case, these beacons are very small size of Bluetooth devices we can install in any part of our buildings. And then we have to basically set up a receiver called a LoRa receivers, which you can use to transfer the location information through internet to cloud application. Because LoRa is basically a wireless technology-based device which offer the long range, low power and secure data transmission for machine-to-machine transmission and IoT applications. Maybe in futures you will be seeing a lot of application of this indoor positioning, because you know that suppose you have a very big hotel, and suppose you want a different activity in the different part of this hotel. So and your people are very new about it, in this region. So how they can get the location of the internal areas. So for this purpose, this technology is very, very important. And here how it works basically, basically these beacons provide the information to the this LoRa receivers, and then you have to definitely you have to install one app into your mobile, and then they can track your location, and easily this information can be transferred through internet to the cloud, and through cloud we can serve the better maps, or also can track the location of the object inside the indoor system. So this is a very important area where the similar concept of GPS can be inbuilt in-house, and locally you can build this location-based services for your IoT applications. How it works basically, triangulation terms what I use, I will not go in detail because this session is about the applications. So you can understand here, this is the Bluetooth 1, 2, and 3. This is a location where this is the location of the object. So when the intersected area, we can basically we can get it. So signal in the case of GNSS, we need signal from at least 3 satellites. The same concept we required the signal from at least 3 Bluetooth beacons to get the location of the object inside a floor. So this is the idea what we follow, and you can further explore it if you have interest here. But here the accuracy is very nice, around 15 to 20 meter accuracy, similar to GPS or GNSS you can get inside the cemented roof as well. So if you use this technology together, you can build a different type of GIS application called mobile GIS, which is a integrated software or hardware framework for the access of geospatial data and services through the mobile devices by wireless or wireless network. So here your mobile device is used as a medium to execute the GIS, where the location of your object or your own location is playing a very, very important role. Here you can track the location, but same way you can use most of the GIS activity, either it is a data creation, mapping, geotagging, data analytics on the fly using this device. And there are a number of applications of mobile GIS. There are 2 major applications. Of course, if you have the mobile GIS with you, then location-based services you can definitely invoke. And same way, you can also use this as a field-based GIS. Field-based GIS means when you are in the ground for the data collections or for attribution purpose. Same time, you can also perform your mapping activities, data analytics activities without having any specific like a computer or GIS database available into your local computer. So if you come to the societal application access of GNSS, there are number of applications already I discussed about it, but some of the case studies I would like to show you where successfully we have implemented or tested the system for very important areas like disaster management, healthcare, or maybe like a Manrega program for government of India where the rural this employment guarantee scheme is running. I'll be showing some examples here. So you know that types of location-based services what are available today. One is the maps and navigations. When I talk about the maps, it is a maps, routing application, assisted navigation services. Then we have the tracking services, real-time traffic updates, vehicle tracking, friends and family finders, information services like local contact search, white yellow pages, city guides, user-generated contents. Then we have the applications like context advertising, social networking. These are things what we can basically perform by using these location-based services. You must be using LBS through popular customer services these days. Some of the examples are like a Ola, Uber, and other cab services you are using in the city. How they are getting your location. The drivers are not asking you where you are standing. Simply, you can also track the drivers, either your cab is coming or not. And suppose you are booking your cab, how you are assigning the job to the drivers. They are using the LBS. They are basically getting first your locations, and then they are telling the nearby cabs. In fact, in their mobile, in their maps, very nicely you can monitor it. These are the very typical example. So you know that here Google has developed their mapping services for their own application and shared API with Ola and Uber. So what they exactly do, they develop a very different type of business model here by using the Google Maps, and they are serving to their customers. Then you can see that after innovation of this LBS, a different type of business models are emerging today, and this is one of the examples. So online food ordering and delivery platform like Swiggy and Zomato, they also use the similar kind of location-based services to serve their customers. You may be using it. Then we have the traffic map in the Google Maps, Bing Map, ISRO Bhuvan, Map My India. So traffic monitoring, a real-time mode is happening through this LBS. Locating point of interest in the Google Map. Suppose you are standing in a particular location. For example, I'm in Dehradun right now. Suppose in the IIRS campus, and I'm looking for some very important point of interest or some interesting point for me, then I can get very simply through the Google Maps. You can use this system, or you already using for store locators like medical services, mobile phones, shopping sites, and all. For emergency services such as 108, earlier now 112 services are basically using the location-based services. Real-time tracking of any moving object through GPS, weather alerts and advisories, location-based mobile advertising, sending a mobile caller's location during an emergency call using advanced mobile locations, and many more. Already you people are practicing this such kind of location-based services in your daily life. This is one case study what we have done sometime in 2013. I will start from that. Basically, that time you may be knowing that in Uttarakhand state, in the Kedarnath region in 2013, there was a very severe disasters in the month of June 2013. So that time there was a severe damage to this region, and in fact there was a big loss to the humanity there. So that time, for damage assessment purpose, we use this location-based services. We design this complete infrastructure, computation structure, and then we use the student community to do the damage assessment of the disaster-affected region. And this was a complete workflow. Basically, in the mobile, we developed a mobile app. The GPS was used for getting the location of the student. Through the GPRS, data was transferred into our servers, integrated together. Then mobile application was developed. It's a complete flow what we designed. And finally, this project was named as a Map the Neighborhood in Uttarakhand. And we do the damage assessment of the buildings and other infrastructures like a road, bridge, culverts, and landslide, riverbank erosions, damage to land cover, natural resources, point of interest, and so on. See, all these forms or data collection forms were designed in the mobile apps. And this mobile app was looking like something like this. So as I told you, it can collect the information as a survey map, It can also do the mapping activities, point line, polygons, this geometry you can create on the fly. It can get the location on the fly, and that time the internet connectivity was also a big problem. But what they did, they went to the field, they went to their village, and they start collecting the damage information. And whenever they are getting the internet, they start pushing this data to the server. So this way the system was designed. And you believe me, this is a very complex or very tough terrain here in Uttarakhand. Most of the part was basically damaged by these disasters, but the student community, what we mobilize in that location, because they belong to the local areas, and they did this damage assessment very quickly. Around 19,559 damage points they collected by using this location-based services, and the location was basically received into the servers in the near real-time mode. And then we could use this data for damage assessment and generation of different type of reports for the government for the rescue operations or for the further infrastructure development activities. And this was the detailed data what we received and we stored in the system. And this data was very, very useful for the planners and decision makers to make the effective development program of this damaged area. So later stage, when the data was received, the complete maps were generated in the normal GIS environment, because you know that in the remote sensing, you cannot get the 100% accurate observation through the satellite. So what you need, the ground information to complete the data or improve the accuracy of this data. So this was used as a ground data. Then we complete the mapping activity and submit a report to government. That time very nicely within very, very short time periods, and then you can understand the power of this technology. Second case study, I would like to tell you about the GPS-based online vehicle tracking system using free and open source GIS. This is another activities. Basically, we develop a small mobile app and then simply deploy this mobile app to the mobile device of a driver in a cab or in a vehicles. So then we are able to track their location on the fly in real-time mode using this GPS. So we can see that where they are moving, what they are exactly, basically how much time they are taking and all. So this was the experiment and successfully it was demonstrated. Third studies for the healthcare using this data, healthcare monitoring for these hilly regions. So where basically a similar mobile app was developed and for the data collection purpose, and simply the location was trapped immediately or maybe automatically by the system and transferred to the server, and we could manage, we can map all the health infrastructure facilities in our region of interest. This is another important activities what ISRO is executing in collaboration with Ministry of Rural Development in Government of India. This program, our product is called Geo Manrega. You may be knowing that this is one of the biggest employment guarantee scheme of a government for the rural areas. You know that what we do here under these activities, we develop the mobile application and we provided this mobile application to the last level engineers or surveyor in the field, and they start collecting the or geotagging the different type of assets what they are building in the ground under this Manrega programs. And then we basically geotag more than 5 crore assets into the system. And you can still see this website live in the Bhuvan. You just search Geo Manrega. So there you can see how all the infrastructure development programs, whatever we execute or under the Manrega programs, are being geotagged, and their location when we have, then we can we are maintaining the inventory. And this kind of exercise is very useful for the for transparency in the system, because if some infrastructure is built under Geo Manrega, so nobody can claim or can initiate the similar kind of activity in some other projects. So this is another interesting application here. So you can see how many such points generally collected. I have selected only one class called NRM in the rural drinking waters, like a soak pits. How many soak pits are created in this region under the Manrega programs? So easily I can map, I can see the data in the real-time mode. And so monitoring of the project is becoming very, very easy if you use this kind of LBS. This is another case studies. You may be knowing about a very ambitious program of Government of India called Amrut programs. So under the Amrut programs, they are developing the master plans for different small town in the country. Under these programs, around 400 towns mapping is already completed, and in fact, in phase 2 of Manrega, another 4,800 towns are being taken for the mapping purpose. But you know that mapping activity, of course, they can do by using the satellite imageries, they can do using the drone imageries and all. But for the geotagging of their ground information with the map features, so we need a mobile app. So what we did, we developed this mobile app here in IIRS, and basically the purpose was attribution of urban utilities facilities as per the defined guidelines and standard of Amrut. So here we use the concept of crowdsourcing, what yesterday Kamal was discussing about it, and the participatory approach for the field data collection and attribution of the map features. So here you can see this is a complete technology what we use for, and the computation architecture is also shown here. We use the completely open source technology like a PostgreSQL, PostGIS, PHP, Web 2.0, and Apache Web Servers. And mobile app is developed for the Android platforms, and the server dashboard is for Windows and Linux operating system. This is a complete flow of the system, but here time is very less. I will not go in detail, but for your knowledge, this is a simple client server applications what we develop, and the data is transferred from the client to server. And similarly, server to client also, we start sending the notification to the surveyor so that if they have some problem in the data, they can correct it immediately when they are in the ground. So this is the background of this app. The app name is Sankalan. Right now, it's available only for government users for do the mapping activities. And here, Town and Country Planning Office of Government of India in New Delhi, they are basically supporting these activities. And here the complete system is designed, developed, and beta version was released. And then there are features like we can do the attribution of 350 plus map features of approved programs. Mobile app is made available for the feature-wise attribute collections rather than GIS layer-based attribute collections. System will automatically restructure the map features and organize it as a GIS layer as per the design standard. And you can use this data app as a multilingual support, which is available in Hindi and English language, but you can always translate this complete app and data structure in other regional languages like Tamil, Telugu, Malayalam, and all. And the collected data can be geo-visualized in 2D and 3D domain, and you can export this data as a CSV, XLS, and KML file. And then the web-based dashboard is also available for data visualization. This is a typical workflow or a GUI of this mobile app. Name was Sankalan. This is start survey, edit data, view data, upload data. This is national highway, state highway, major road, and all. And this way you can see the screenshot here. And then a few more screenshot. This is a dashboard. So you can monitor the growth of all the survey activities. And if any team is not performing well, then you can also trigger or send the notification to them from the server side. So you can see here for the experiment purpose nearby our locality, when we did the mapping, very nicely the data was coming and the location was automatically taken from the GPS, and then it was transferred to the server, and easily it was attached with the map features. So with this, thank you very much. Since today it was a little difficult time because we have to here conduct 2 sessions in a day. So we try to make it as shorter as possible. So I hope you'll use this content for your future applications for all the participants. Thank you very much.